Because I don't think they want gases
It's going
escaping.
to be negative.
Labs are negative,
The labs are negative.
right? And they take, if you look at the doors, they take some of that positive air from the hallway.
Yeah.
Underneath the door, they move that into their bed.
Okay.
I'm trying to remember how it's ducted, but I'm pretty sure the hallways where the wet labs are also served by DOAS 1. They have, it's just the ends of the unit that are the rooftop units.
Okay.
But those hallways that go down outside the wet labs, those are also fed by DOAS 1. And I think what they do is they pressurize those.
And down the core is off of us too.
Yeah.
So the biggest thing is that what they don't want, if they're doing,
right, you don't want
to do a major experiment.
Yeah, you don't open the door to the lab and all the crap blow out in the hallway. Right.
Right. You have to keep it in the lab.
Okay.
So that's why they want it slightly positive.
Yeah.
All right.
All right. Well, let's go down to the 6th floor and we can show you some spaces. Since we just kind of came to it, I'm going to talk about these are the 3 H class rooms. You got this one, you got 2, and you get the one around the corner here. These are the ones that I was telling you about that are H classes, hazardous classrooms. They are, I'm going to mess up this word, intrinsically safe. So they're all explosion proof. That's why you have a bunch of these crazy electrical fittings that kind of pretty much isolate the rooms. So we installed the monitoring system, which I'll get into. But if there's a monitoring system in there that I'll show you, but if it goes into alarm, we do a horn strobe on the outside, and then there's a bell on the inside that alerts the people, like if they spill something or something happens while they're in there, it alerts them to leave the room. And then there's also there's also a pull station, which if they pull this, it'll also set off the alarms too. So we'll go in. Can we? There's no. I think we can go in. What's that? Okay. So we have the exhaust. This is the exhaust. It's going out to one of those exhaust fans of the 7. This is the DOAS 2 supply. Looks like they labeled how much CFM they're getting out of each one. So you can see that this is also a negative. All right, so this crazy contraption. This is an MSA X5000 gas detection system. It's equipped with 2 sensors. This one is O2, and that one down there is lower explosive limit for propane. They wanted to monitor volatile TVOC of the gases, and the one that has the lowest concentration is the propane for explosion proof. So pretty much, if O2 depletes or there's a buildup in propane, this thing will start flashing red, and then it'll trip the bell and then the horn strobe on the outside. There was a bunch of, again, we have more of these EY, they call these EY fittings to kind of make sure none of the gases escape through any of the conduit.
And this will be one of the alarms on the BMS that will be.
So we monitor from 0 to 25% oxygen. So you'll see in the front end, you'll see a level reading. It's usually about like 20.5% O2, and then this one will obviously be 0 because it's not detecting any propane.
So does it sense an alarm high and low?
This one's just low. This one's high. I don't think this one. Yeah, this one will only. There is no real. Well, it's a good question. I don't think they really consider high O2, but I can look into that. But definitely low. And then anything above pretty much 0 on this guy down on the one toward the floor.
Because high O2 is flammable, so it might read both.
I think this one is just like if anything happens and you're
anything out of range.
Yeah, anything out of range.
Okay.
They want to make sure that people that come in here and they have oxygen to breathe. And there's 3 of these rooms, and they're all, one's like a storage, the other one's a waste, and the other one, I forget, they all have different functions. Any questions about the MSA gas monitor? We purchased this through a company called NECI out of Connecticut, New England Controller Institute or something. I can get the information, but you can call them for service. I can get all the contact information.
So that should be included all the O&Ms, correct?
Yep.
All right, then we're good.
Yeah. So trying to remember what they had for service. I forget. So forgive me, but I think it's a yearly, pretty much, service of the sensors, recalibrating. We paid. We have a calibration cert that was where we did to calibrate all this stuff and to certify it.
So that's something that we'll pass on to EH&S at Brown. We won't touch any of this. Yeah, they'll handle that.
They have their own department.
Yeah, we won't do any of
Okay.
that. Yeah.
All right. Well, it's
And
there.
they may want them if it's a warranty item. They may. That's up to them. That's Brown's call.
Okay. All right. Any questions about the H classrooms? I think that's a light.
Oh, okay.
I think
It's a request to exit for the door.
Oh, is it?
So
Explosion proof, huh?
Yeah.
Wow.
So if the card reader itself, it gets you in, but then when you go to exit,
Yep.
so they don't get all these alarms, that's what that picks up.
Okay. Sweet.
Assume above the other doors, but they're not quite as big.
Oh, I get it.
Why?
yeah,
is-
everything's in here. Explosion. That's why everything's like kind of like
Yeah.
heavy duty grade.
Okay.
All right, so the wet labs are kind of interesting. So again, as I said, so DOAS 1 gets you all the fresh air, but what they did is they installed a Mitsubishi VRF system for the primary heating and cooling, and that has its own. We're monitoring it, but that kind of is controlled on pretty much on its own. I think you can send it some commands from the BMS to be either in heating or cooling. There's some things you can change in set points. It'll give you like a change of filter alarm. So there's some things you can do from on the front end, but mostly it's kind of its own package controller. So these wet labs, they'll have this one. I think is the smallest one. So I think this one has 4 or 5 head units, and one thermostat, which is, if I remember, I think it's on this wall over here. But there's one thermostat that pretty much controls all these head units. So in the BMS system, you'll see, we call them like leader followers. So you have like a one that's where the thermostat's wired to, which pretty much then kind of tells all the other head units to also be in the same condition. I think some of them may have like different filters. Like obviously, if like one hasn't been changed, a filter cleaned in a while, they can have their own individual like alarms, but mostly they all control off of one room thermostat. And then each room, so if you want to come in one of the rooms, again, this is the, did I say Mitsubishi? Daikin. It's a Daikin system, sorry. Mitsubishi on the mind. So here's the Daikin thermostat. Again, like I said, it's its own package controller. We monitor it, but we pretty much let the Daikin thermostat do all the work. This guy down here is a an R410A refrigerant monitor sniffer. So the intent is that if one of these things were to get like a leaky connection or something, and all of a sudden it starts dumping all the refrigerant, because you got to remember there's only 6 compressors. Did you guys get the Daikin training yet? I don't know.
Mm-hmm.
Yeah, you did? Okay, so there's 6 compressors on the thing. So the idea is if like all that refrigerant, because it's all comes dumping into this one small little space, you could have a bad situation. So it's designed so that this catches it, and there are these isolation valves on the refrigerant to close. So what will happen is this detects refrigerant. We isolate the refrigerant lines. We shut down the entire system, and then we send an alarm to the BMS. So there's its own sequence on just monitoring that. Again, I'm not a Daikin rep, so I don't know all the ins and outs of every system. But any questions on any of this?
It's like any split system.
Yeah.
They're all the same.
All right, we'll move on to let's see what's next.
Hood.
Oh yeah. Let's talk about the Antec system. Thank you. So VRF does all the heating and cooling requirements. The air is a system that I provided, which is called Antec, which is a lab air system. The way it works is you got kind of three things. You got a supply air valve, a fume hood valve, and a general exhaust air valve. So the supply air is constant. The fume hoods open and close based on the sash position. So you open up a sash, it requires more. It controls to the face velocity. You need to get that. Frank, help me. It was 110 feet per minute across so going into the fume hood. So those make sure they maintain that face velocity. Let's walk over there and show you guys a little bit. Sorry. So I'll show you. So just so you know, so as they open these hoods, and you can hear it, the Antec will increase. So now the fume hood exhaust air valve, and when I say it's an air valve, it's different from a typical VAV box with the rotating damper. It's a plunger style. It goes in and out. So it's a Venturi valve, and as the plunger goes in, it restricts the airflow. So it's a little bit different than a typical VAV box. But as you open this, the air valve pulls out of the throat of the Venturi valve, and more air is brought across the face velocity sensor. Now, so what happens is they need to keep this room into a slight negative, as we were mentioning earlier. So as more of these increase and more of the fume hood exhaust air valves open up, well, what's going to happen is now that we need all the air coming in this way, we're going to restrict the general exhaust, because there's three. You got to remember there's three types of air valves: supply, general exhaust, and fume hood exhaust. So because these are all opening now, these are open now. The general closes, so now we force more air through the fume hood. And as these all close, the fume hood exhaust air valve above the ceiling will then also close, and then the general exhaust air valve now can open up more. So that's how the lab air system works, and it's all based on pretty much reacting to these. Make sure that the air goes through the fume hoods.
So if we hear whistling and howling and drafts, we call you.
Yeah. So we don't directly service it ourselves. We purchase it through Buckley. Mm-hmm. So Buckley reps Antec. So if it's an Antec problem, we can get you the Buckley. Buckley has their own service department, but we can help you and make sure you know.
So here's my problem. You've got three different sets of dampers that any one of them could be causing any one of those problems. Mm-hmm. Who do you go to first?
I would go to Buckley.
Okay.
Yep. I mean, we can help you. I'm not saying don't call us.
Yeah, like say it's whistling. We know we got an air problem somewhere, but how do we know it's not the dampers on the fan or the dampers here or one of the valves? Yeah. I mean, there's no way to know for us to be able to tell what it is. So
what's that? First call. Yeah. You guys can. I mean,
I think that's what it's going to be. First call is you, because you can have to tell us what's wrong, because I won't know if it's that valve, or that valve. There's
so every one of these air valves. Again, so we're monitoring. So the way it works, so we're also monitoring these air valves too from the BMS. We pretty much look at it as like one room. So what I mean by that is, we're communicating to the supply air valve, is like kind of like the leader of the Antec control system. So we bring our communication wire to the supply valve. The supply valve gets all the information from all the other general exhaust valves or the fume hood exhaust valves. So on the BMS system, you should see damper or actuator position and flow, and then the supply valve will tell you. Well, and then if you look at I'll show you down in the BMS system, but we call them fume hood FHVs, fume hood valve, and they'll show you the face velocity, what it's reading for face velocity. We'll show you the valve position. Every one of these different valves will show a different position, so you can also probably diagnose a little bit too and say, oh, hey, this one's 0, it's closed, but it's reading 100 feet per minute across the thing. So what's going on here? Either we got a slip shaft or something mechanically is wrong. But yeah, that's that's if it were me, if I were in your shoes, that's what I would like. You can still look at the BMS to kind of all start putting some of the pieces together. Still, it's not that it's completely like on the moon. There's some things that you can still do.
Okay.
So experience-wise, so like the BMS first, see what's going on. You can tell by the come up here and look at what they're doing with the hood. 5% of the time, though, you come up here and get the hood blocking the vent.
Yep.
Right? Or they take use bypass the hood sash. They do that a lot of times because they're trying to put a bigger instrument in.
Yeah.
Closer. Back down.
Okay.
So those are things I would look at first, and then if that all clears, then that's when you get involved with.
Yeah.
They'll ask you questions. So
Yeah, you're right, because there's a few times where we come in, all of a sudden they put an oven in there or something, and it's like right in the taking up, a lot of the area across the thing, and it's struggling. So there's also that. So those little excuse me, green displays. Those are the fume hood controller. They'll do an audible chirp. I think you may have heard of it or heard it already. They'll go in the alarm, they'll flash, and they'll make an audible alarm that they can silence. There's a silence button, but then after I think 2 or 3 minutes, it'll re-alarm. So it's not a permanent silence, but there is that too. And that was all balanced already, so everything should be pretty good. I think that all passed.
balanced ways. Balanced with the basic building balancing, then you have a certification.
Over there.
Yeah.
Mm-hmm.
That's something they have to do once a year. Brown would probably take
Yeah, not us. So we're responsible for anything on the roof. They're responsible for everything in here.
Okay.
Yeah, that's the rule.
Any questions about the lab air valves? All right, and then I think the last thing we'll show you a non-lab space at the end. So this is a typical non-lab space. This is this room is being fed from the existing rooftop air handlers. So this is taking the building air. And these are Johnson controls. When I say Johnson controls, these are our first party controllers here. So those are a typical VAV box. Just the standard rotating VAV. It's pretty standard. On the wall, we have our thermostat, the Johnson thermostat, and a CO2 sensor. If the CO2 starts to elevate, we'll try to bring in more fresh air. We'll reset the minimum air from the VAV box up to get more fresh air in. Pretty much the common area, like the big common areas, have the CO2 device, and then we have control of the heating here in this space. So our standard JCI thermostat. I don't know. Do you have these on the lower levels too? Can't remember if the thermostats changed.
Some spaces.
Yeah, there was a
like in J&J.
Yeah, so we had upgraded some of the spaces downstairs. I think you may be familiar with the turn dial. Those are the older ones, and then they upgraded the thermostats to these touch screens. They're not the best, admittedly. They take a little bit of manipulation. I try to get a little bit of thumbnail in there, but you should be able to hit the up and down air. There we go. Once it starts blinking, now you can go all the way up. I think 74 is the ceiling. Now I'm going to explain our set point range here in a little bit. You can see that's why I'm not a big fan of these, but the 73. It might be 70. All right, it looks like it's 73. So we can go as high as 73 and I think down as low as 68. 67. Okay. So I'm going to just go back to 70, keep it neutral. You're probably going to get a couple of complaints about these. Anyways. All right, so the way these work is just because they see a set point of 70 doesn't mean that the space will get to 70. So the thing that kind of like make people always question, it has a deadband built into it. And it's a 4-degree deadband, 2 degrees high and low. So if somebody sets it to 70, what we're going to try to do is we're going to effectively try to heat up to 68. So if somebody puts in 70, I have it 70, but it's not getting 70. It's only 68. Well, it's working perfectly because we're not meant to get to 70. 2-degree deadband.
Can we change the deadband?
Yep.
Let's
Yep.
change the deadband to 1 on all of them. 1 degree each way.
Okay.
2 total. Just because the 10 that's here,